Okay, hello everyone. I think it's already 6. So I might just start because we only have 1 hour here. So hello everyone. Who doesn't know, I'm Aurimas and I am a solutions architect here at neptune.ai. And we decided to do a workshop on Azure ML pipelines. It makes sense because we are working with our clients day to day to solve different problems, and we have quite some clients that are actually from Azure, using Azure services. And today we want to show one of the examples that we prepared. Okay, so I'll just start on with a short introduction. So the agenda, maybe around questions. So I'll probably not be answering any questions during the demo, but during the workshop, but feel free to ask me any, and then I'll just answer everything after the demo. So the agenda is as following. So I'll start with introducing what are the stages of ML machine learning training pipelines. Then we will go to see into how Neptune fits the bigger picture and how it connects all of the different systems in the machine learning lifecycle. Then I will go very briefly through a very short intro of a project that we're gonna build in the notebook. Then I'll go through the prerequisites that are required for you to be able to create Azure ML pipelines and Azure DevOps ci/CD pipelines. And then we will go on and build from a fresh project, a Azure ML pipeline using Azure ML SDK. And then on top of that, we will also be integrating it with Azure DevOps so that we can kind of say that we have a almost productionized system, or at least one that can be very easily productionized if we add some additional features to it. So how does it all start? Usually, probably you all know that machine learning training pipelines are started in experimentation environments or development environments where we use our favorite IDEs or Jupyter Notebook, which is also an IDE, to experiment with machine learning models. And this is how the pipeline, oversimplified, I would say, pipeline usually looks like. We do some data analysis, validate it, prepare it for training, train the model, evaluate it, validate it, and that's it. Usually, that's what you need in experimentation environments. And neptune.ai in this picture kind of solves the problem of centralized metadata management, so that you can log all of your experiment metadata, like data sets that you have been training your models on, all of the hyperparameters of your models, architecture of your models, the evaluation parameters of your models, etc. And then once we kind of move away from development and experimentation stages, we move to the stage of automated pipelines. And these pipelines are usually scheduled with a specific tool that is meant specifically for machine learning pipeline orchestration and offering. And tools in this space vary a lot. And one of them is, of course, Azure ML pipelines, but you can think about tools like Kubeflow and Airflow as well, because they fit the purpose. Once these pipelines are deployed, usually we start deploying them from the experimentation environment directly, but eventually what we want to actually achieve is connecting it via a version control system, meaning that pipelines eventually should be treated as an artifact, as a piece of code. They have to be versioned themselves. And the build and testing of the pipelines should happen as we make changes to the code of the pipelines. And once we kind of traverse the entire Git flow pipeline, only then the pipelines are deployed to production. When it comes to Neptune's high-level architecture, this is how it looks like. So on the very top level, we have a workspace, and I will show you very soon how it looks like. Then we have a project, and a project is comparable to a use case, machine learning use case. So for example, if you have a ranking model, it would be stored under a single project, and then you would have runs that are equivalent to your experiments. Okay, and once you actually perform an experiment, then you save your model artifact as a model version. Single run could have multiple types of models. It could be XGBoost, it could be neural network of some sorts, it could be, I don't know, it could be a profit model, for example. And then each of these model types would have model versions, and each of these model versions are then a candidate to be deployed to production. And that's a short intro of what we are going to do. And I will just then start with the initial stage as via this slide, the experimentation stage. And let me find the notebook. 1 second. I'm lost. Here it is. So what we will actually be doing today is training a time series model. Actually, the training of a model itself is not the main goal of the session. We'll be mostly working on actually building the Azure ML pipeline and connecting it to the DevOps tooling of Azure. But we need to kind of have this initial phase, and an initial phase is usually done in notebooks. I'm not gonna go and run it, but I will go through the processes that are usual to a machine learning training experimentation jobs. So first of all, we need a model. So we'll be training a profit model on top of time series data. We already have pre-processed data ready, and it is in our GitHub repository. So we'll not be targeting any object storage, for example, just for simplicity reasons. So you can download the data directly from GitHub. And just to make also sure that you know, we have this all of the code that we will construct today in one of our repositories. It is in our neptune.ai examples repository. And under examples, you have integrations and supported tools, and you have Azure ML. So we will be building out all of this step by step today. If you want to follow, you can also clone the repository and do it that way. Okay, give me 1 second. Yeah, so this is the notebook, the initial notebook. We have this same data in the same repository. We do some pre-processing. It's really for this demo, it's really not that important what we do with the data, but we use some utility functions that we have to normalize it, encode categorical data, etc. So eventually we get something like this, where we will be predicting weekly sales, not predicting, but forecasting weekly sales, given all of the features that we already have pre-processed. Then we train our model, and for training our model, we'll also include experiment tracking here to Neptune. And it is as easy as just running Neptune init run and targeting a correct project. We have some helper functions here to do some data munging so that we kind of transform the data to the correct format that can be then used by Profit library. Of course, then we, as usually, we split our training our data set into training and validation data sets. We do some more pre-processing. We create a model, and we basically fit the model. So that's it. So we are not focusing on the whole explorative data analysis part here in this workshop. And then we also store metadata to Neptune servers very easily, just pointing it to a specific namespace of a run. In Neptune, logging of metadata is usually done, not usually, but always done via these run handlers, and they can be created by simply initializing the run and then pointing to a specific namespace, and then we track specific data to these namespaces. How it looks in Neptune, we can very quickly see. For example, let me check. So in this case, this is model config, and model config is then stored under the specific namespace, and you can see all of the data available here. Then we validate the model. So this piece of code actually does not do the validation itself, but what it does is it calculates specific performance metrics, model performance metrics, saves those same model performance metrics to a specific namespace in Neptune. And we can also see it under training well namespace. So if you would go to Neptune, training, validation, and we see all of these metrics saved here. We can also, not only can also, but we will also save some actual plots to Neptune as well. And we do that also by pointing to a specific namespace and using upload method. And this uploads the entire plots, and it will look something similar like this. So you can upload entire images. Then once we do that, we create a model in Neptune, which is a separate entity from a run. We also use init model methods, similar like init run. And for a given initialized model, we initialize a model version. As mentioned, a model is a kind of specific to a certain type of model, and under that model, you would have different model versions for each separate experiment. And once we do that, we add some specific metadata about what type of experiment actually created this model, and do the same thing for model version as well. So in Neptune, it would look something like this. You would have model metadata, which is a model registry, basically. And under here, you would have a already logged model, and here you would have run details that we have just logged, and here you have a URL of a experiment that actually produced this model, and you can just go and click out to it. Okay, and then we also save the specific cursor metrics to the model version, so that we have them both in model registries and in model registry and in experiment tracker. And this is basically it. So this already contains 3 steps in a machine learning pipeline, and we will use these specific 3 steps to build out a Azure ML pipeline and to be able to then automate it. So now we move to a fourth piece of our agenda, and we will look into the prerequisites you need so that you're able to actually run Azure ML pipelines and Azure DevOps pipelines in Azure Cloud. So if you log on into your landing screen of your Azure ML, not Azure ML, but Azure, you will see 2 services that you specifically need, or more of 2 sets of services, suites of services. One of them is Azure Machine Learning. And in Azure Machine Learning, you will have to create your own new workspace. Once you do that, you can click into it, and you will have this. and you will be able to launch Studio, and that's what we want. It will error out a little bit for me, but that's my technical issues with account setup. But here I am back in the screen, and our goal will be to build this pipeline via a Azure ML SDK, and we will be using version 2 SDK, but more on that later. And it will have this form. We will register a set of data. We will then use that registered data to run a data preparation step. Then we will train the model, output a validation data set to the next stage, and we'll do validation in the last stage of a Azure ML pipeline. In order to run Azure ML pipelines, you need two things, actually three things. One is more infrastructure related. All of them are infrastructure related, but one is for you to be able to authenticate and run the pipelines themselves. So what you need is an environment, and environments are basically containers. You can think of them as containers having a certain set of dependencies. So we already have one pre-built because it takes some time to build this container. And in our case, we have already predefined all of the dependencies that we want to have inside of it. And you see that we are installing packages like Neptune, 𝗟𝗵𝘁𝗵𝘁 for integrations, then the Prophet library itself for training. Matplotlib and Seaborn are needed for Prophet to function correctly. Seaborn is not, but I think Matplotlib is. You also have NumPy and 3.8 Python here. To create a new one, you just need to go to environments, create a new environment, and follow all of the steps, provide a conda YAML specification file, and just create the environment. So we have one created, which is called Neptune example, and it has a version tag of 1. Next thing that you need to have in order to be able to run a pipeline is compute. So in compute, specifically compute clusters. And compute cluster is just a set of predefined resources that your Azure ML pipelines can run on. And each step runs in its own container on a specific cluster. I don't know why it's still resizing. Let me check. Okay. The next thing is authentication, but we will look into it later once we will be kind of integrating Azure ML pipelines with Azure DevOps. Okay, so how do you create a pipeline? You create a pipeline. There are multiple ways, of course. You can do it via UI, but we will not be doing that today. Today we will be using Azure's Azure ML SDK version 2. So we have a fresh project here, which we can kind of destroy. And we will use also code from the notebook that we looked into initially to kind of fill all of the elements that we need to do. So first of all, I would like to introduce you to the concepts of pipelines themselves and what the pipelines are composed of. And I will do it by creating a new Python file, which I will name build pipeline. And this file will contain all of the logic needed to stitch up the pipeline itself from different steps. And I'll just, from the very beginning, import some of the libraries that we will need. And these are specifically related to Azure ML's SDK. So what is the pipeline composed of? So first of all, it is composed of elements called components. And there are multiple ways you can define a component. One of them is this simple type of component, which is a command type of component. So what it basically allows you to do is to run a specific bash script inside of a specific step. And today we will actually be composing our pipeline entirely of these command components, because it is, I would say, easier to understand. But once you kind of get a better grasp of it, then you can jump to other types of components, because you could define it via YAML and via Python functions that do not include any bash script inside. So I will be creating the first component here, which I call data prep. And this component will materialize into basically this step, data preparation for training. And right here, we have the same display name that we see in the UI. And it basically reads CSV input from a same remote repository that we used in the notebook itself. And it will have this command running it. So I don't have this file yet, but I will be creating it. And so first of all, we need to define the inputs. So each of the components can have, but not necessarily, some inputs and outputs. And for this, in this case, we have an input, which is the CSV file itself, and output, which will be, I think, yes, the training data that we pass to a next stage, which will be training. And to define a data set, we have to register it. So we had this URI that hosted our dataset. And in order for you to register it, we will also be using some Azure ML SDK magic. Here, this is the data class. And by running it, not even by running, but by creating an object, we define how do we extract the dataset, and this is specifically from a path. And the type is also needed here because it's extracted from a specific URI. We can version the datasets here already, but what we will actually do, instead of versioning the dataset inside of Azure ML, we will actually register it. But each time we do register it, so that means each time we run this pipeline, we will recreate it, not create, but update it, but not update a version of it. It will always have this version. Okay, so where is then this script Python data preprocessing stored? It is actually stored, give me 1 second. I have a specific structure in mind for this project, and I will be creating a directory that will contain all of the components, one of whom is the data preparation component. And in this directory, we'll have subdirectories. One of them will be for data prep, so data preparation. And here we will have a script exactly named data preprocessing. And I'll not code it from scratch and just copy paste the code and explain what we need to understand for it, because this is very simple script and not much is happening here. Sorry, I'm also missing a utilities script that I will be using with this data preprocessing script. In this utilities script, I have all kinds of helper functions that I need to preprocess, transform data for preparing it to be used by Prophet library. So it really has not many things here. So it's very similar to what we've seen in the notebook itself. But if you would look into the pipeline, we see that into the command, we are providing two CLI arguments. One is inputs data, one is outputs data. And we defined them here, and we need to define them here because these objects need to be known before the pipeline itself is created, so that we can pass the paths to these objects to the step of a pipeline itself, and then we can use them from inside of pipeline, so that we can then pass data from separate steps to a upstream step, or downstream step. So we have data and train data arguments, and in here we kind of use argparse library to extract these and use them in our code. So first of all, this is the input data, and the input data in our case is aggregate data here that we registered. And the output, we kind of save the transformed data, pre-processed data, into the output directory that we got from the inputs. It's a little bit confusing, but once you get used to it, it makes a lot of sense. The main thing here is probably to think about it in the way that you need to provide these locations before the pipeline is stitched together. And you can only do that by passing them as arguments to a specific script, or having the script itself as part of the pipeline. Yeah, so the first step, let me check what we're missing here. We are missing one argument here, which is this. And then custom environment names. Yes, custom environment names I'll add later. But we could, yeah, I'll add later and explain them later. So the next component that we want is the training component. And it will look very similar to the pre-process component. It will simply have a different sets of inputs and outputs. So we have display name model training. So that maps to model training task in our pipeline. And as inputs, we have Neptune project, Neptune custom run ID, and Neptune API token. So we need to be able to pass Neptune authentication to a specific step, so that the step inside of it could use it. And we also need to pass a Neptune custom run ID for the reasons that I will explain very shortly. For now, I'll just implement them in the code. So Neptune project that we will be using here today is common project time series forecasting. And right here in Neptune UI, you see that this one, project time series forecasting. That's how this project is named, and we need to pass it to be able to log to it. And we also, and common is because the workspace that we are working in Neptune is called common. That's why we have common project time series forecasting here. Now, Neptune custom run ID, it's not necessarily this how you construct it, but this is something that will give you a unique identifier each time you run it. So that's why I decided to use it here. And Neptune API token, this is something that is a service account in Neptune, and a service account in Neptune can be found here. And it is a basically, as a service account would be in any other system, it provides you the ability to authenticate in automated systems like CI/CD pipelines. and that's why we are using not a personal token, but a service account token. You can assign specific access rights to it, similarly like users. Okay, let me get back to the project. Okay, so we have implemented these, but we haven't passed them yet. Okay, we'll pass them later. Actually, I'll just do it right now because it will be easier to understand what's going on. So instead of just doing a straight on script, we will just implement a function that we will later run to create the pipeline, and the function name will be compose pipeline, just a very intuitive name because we will be composing pipeline by running this function. And maybe without any further ado, I'll just also implement a entry point at the end of the file so that it's not confusing anymore, and we will just run the compose pipeline function and pass Neptune project and Neptune's custom run ID as a parameters to functions. So yeah, so that we don't have more of these red parameters flying around. Okay, so we have now inputs. So we have custom run ID, API token, and Neptune project to be used in the script. Now we are lacking the train source dir. So this is something that is not necessarily important of how you name them, but it's just it is important. So it is very actually important. So this source dir represents a path in your project from where to basically copy the code into your task, Azure ML pipeline task. So right here, data prep source dir is components data prep, which is this folder. So basically, it copies the contents of this folder into your task, and that's why you can simply call the script, the code, by running Python data preprocessing, because this is now the working directory for that specific task. So now we're gonna implement the train component train component basically, and we will be implementing it into train source dir, which is components train, meaning that we need to create a new directory named train, and in here we can now implement the training script, and it will be called train.py again, as we named it in the pipeline right here, train.py. And I'll just copy paste the code because it is something that we've seen already in the notebook, so I'm not kind of creating anything new. It's read it a little bit because the Prophet library itself is not installed here, but this is where we will use the Neptune project, Neptune custom run ID, and Neptune API token variables that we have passed into this script. If you remember, right here, as inputs, we passed all of these, including the train data. So in the train script, now we can use them, and we are exporting them as environment variables because they are all needed. Not all of them are needed necessarily as an environment variable, but it is a good idea to expose them as environment variables because then you can run Neptune's functions without necessarily needing to pass those parameters to the function itself, making it more secure and not needing to expose, for example, Neptune's API token into your init run method. So we are initializing a run, Neptune run. We then are reading the input training data file. The select first file is simply needed due to Azure ML nuances. So this is just some helper functions. This is also just some preprocessing, happening here, model training itself. And as if you remember from the notebook, we are using the same functionality to save metadata to Neptune and to save the model itself to Neptune, but we are saving here model to the actual experiment metadata level rather than model registry. Then we create a model validation data frame because we will want to pass it to the next step of the pipeline. And we are doing it by exposing the, not exposing the, but using the outputs validation data path so that we can, this is the output that we have, so that we can then pass this data to the next step. And if we would look into pipeline, here's how we managed to do it. So we are also passing as an argument validation data path, basically, which we are then using inside of the script. Okay, so we have now implemented train component as well. Next one is the validation component. Let me find it. Yes, so validation component is once again very similar to training component. Oh, I think I unintentionally even named it train, but this is actually validate. And it does model validation again as per display name. This is the final step of model validation. And we have validation source dir, and validation source dir for us is components validate. And once again, we have to implement it then under components validate folder. And here we need a script called validate. That's what we will create. And this script has this data. Also, again, something from the notebook that we've seen previously. This is just some helper functions for AzureML. And we also extract some variables. We also need the Neptune project, Neptune custom run ID, Neptune API token, because we will need to reinitialize the same run in each step so that we can tie everything that is happening in the same pipeline under a same Neptune's run. And we reinitialize a run. Let me see where we do that. Yes, so we init the run, but we reinitialize it under the same custom run ID of Neptune because we are exporting this environment variable. You could also pass this value to the init run itself as a custom run ID, but this is why it's easier to navigate when we do that everything at the top of the script. So we just create validation data sets. We calculate some performance metrics on top of the validation dataset instead of training dataset. We store all of them into Neptune's run under train/val namespace, parent namespace. We also save the plots, same way we did in the notebook. And then we create a model version, a new model version. So if we already have a model, we will not create a new one. We'll create only a model version. We'll only initialize a model version if the model itself is already present in Neptune. And we initially change its state to staging. So in Neptune's model registry, if you would go here, we will see that we have stages, right? And you can manually change them to production, archived, or none. And this allows you to manage lifecycle of machine learning models in your organization. And it is what I believe each model registry should have as a capability. As mentioned, we are doing it programmatically. And then saving some additional metadata to runs so that we can identify which model version was saved under a specific run and vice versa, which run was producing the specific model version. So we'll not go any deeper into this one. Basically, we are saving now the model-to-model registry. We have the third step. Yep, we have all 3 steps of the pipeline now. Additional thing that we need to do for the pipeline to be able to run is authenticate. And we do authentication with this piece of script right here. Let me paste it here. This is something very specific to Azure. So it is also something you will find in their documentation. And this is how you authenticate if you're running from a automated piece of code and not necessarily a notebook. If you're running a notebook, authentication would be different. Now we are lacking Azure subscription ID. Yes, so these variables are very important for you to be able to run the pipeline. So this is just your subscription ID. So basically your account ID, AzureML account ID. So resource group name that you have created, and AzureML workspace name. So if you would go to AzureML workspace right here, you will see default directory, Neptune demo. You'll see that this one is called Neptune demo. That's what we expose here, basically. Workspace name. And then we authenticate to this specific workspace. And credential we are getting from these authentication methods of Azure specific CPU cluster. The next step. So we have all of the components that are needed to stitch up the Azure ML pipeline. The next thing that we will do is actually create the pipeline itself. And we do that by creating a function which is decorated with specific SDK, Azure ML SDK decorators. We actually imported them here, so DSL. And you decorate your pipeline function with decorator the DSL pipeline, and then you provide compute target to it. This is where we did it, CPU cluster. As you remember, if you remember, I've mentioned initially that we will need 2 things. One of them is compute clusters to run your pipeline, and this is where it is, CPU cluster. And this is exactly what we just did. We provided this name. Description doesn't really matter too much, but this is what we do then. We define a pipeline, and we do that by defining these data prep job, train job, and valid job, which you can see also in the pipelines here. Each of the steps are right here called like the objects that you create in the code. And we also then provide inputs from our pipeline steps as outputs from our pipeline steps while creating these components. If you remember, these components are data prep component right here, and train component right here. And by calling data prep jobs output, which is train data, we can pass it to the train component as an input, basically. And the next thing we do is create the pipeline. Pipeline itself, an object, And then we create a pipeline job. This is how we actually initialize the pipeline. And this is how we get the output of a pipeline in real time. And that's it. This is how we create the pipeline we have just seen in Neptune, not Neptune, but Azure ML Studio project right here. And this is also how we connect it to Neptune. And now we need to execute it. In order to execute it, we could do it locally, but I don't have credentials here. So I will just go straight to implementing a CI/CD, part of CI/CD for this. And for CI/CD purposes, now we can jump into another piece of service that is provided by Azure, which is called Azure DevOps. Let me see. Yeah, we can find it here. So Azure DevOps organizations. So you will also naturally you will have to have a DevOps organization pre-created for you. So luckily I have one. And in this you can have multiple projects. You also already have one. And when creating a pipeline, you basically point to a specific YAML file that defines the pipeline. And let's first create our YAML file in our project. And I will host the YAML file in a new folder that I will call Azure CI. And here I will just create a new YAML file, which I will call Azure pipelines.yaml. Azure pipelines.yaml. And I'll just copy paste due to time constraints the code that I have here and just explain how it works. So in Azure DevOps pipelines, you can define some specific rules about when you want this pipeline to be triggered. So in this case, it's very simple. We just trigger the pipeline once anything is pushed to the main branch of a specific repository. And then we define some stages for this pipeline. The first stage, not the first stage, but the only actually stage in this pipeline is called CI. And in it, we have multiple jobs. Again, only one job, which we call CI, which will be using a specific right here image to be executed against. So this is, you can imagine a Docker container running underneath. And then we have steps, and steps here comprise our CI/CD pipeline, basically. Not all of them are implemented, but I wanted to have them here just to kind of clarify that they need to be implemented in order for your CI/CD, machine learning CI/CD pipeline to be kind of probably not even production ready. There would be more, but this is very close to production ready if everything is implemented. So first is just copying the requirements.txt file, which is not here yet, but I will add it here under this same folder. And requirements for this to be successfully ran are not many. We simply need Neptune client. We need Azure AI ML and Azure ML some specific packages. This is requirements for a CI/CD pipeline to execute. This is not for the Azure ML itself. So right here, we just install all of the requirements. Then what we should actually do is linting. So you should lint your code. Then you should unit test your code, and you should integration test your code. So we haven't implemented this for this specific workshop, but you should implement it. But what we are really interested in is this is build pipeline. So basically, we will be building a pipeline using the code that we have defined here. Since Azure CI will be executed at the root level, we can reach this code from specifically the same folder. And this is where we'll also be passing some environment variables to the pipeline job itself. And this is also important if you would look at the pipelines that are created in Azure DevOps, which is only this one. If you edited it, you can see that there are variables selection available. And here you need to kind of input your specific secrets. And these secrets are service accounts in Azure, for service accounts in Azure, so that you can authenticate using automated pipelines. You can create them either via UI or via CLI. I will not go too deep because we are running out of time. I would rather show a successfully running pipeline here, because this is more of the administrative stuff you need to do. Okay, so now how do we point a specific pipeline to Azure DevOps pipeline to a specific YAML file? Very easy. If you go to pipeline, you can create a new pipeline, and then you can choose where to point to. And I have all of the code needed for this example in my personal GitHub repository. I'm not pointing to Neptune's repository, but it's the same code that is in Neptune's repository. You will also need to clone the repo and kind of create your own in order to do this. So right here you can select your specific repository that you're interested in, and this is Neptune demo. And you can then select the existing Azure Pipelines YAML file in the main branch, and you will be automatically pointed to it. So I have Azure CI, Azure Pipelines. Once I press on it and create the pipeline, you will see something very similar to this. It will be created. It will have no runs yet, but eventually it will. So how does this pipeline look like? It looks like this. It has all of the steps that we have outlined, but we haven't yet implemented compare models plus promote and deploy model tasks, not even tasks, because we are running these scripts outside of Azure ML pipelines themselves. But I wanted to also show what these do, and I also have them, don't have them yet here, but let's create them. And they would be hosted in a specific directory that I called scripts. And in scripts, I would have two scripts. So one of them is model promotion. What does this mean? This is already a automated kind of promotion script, which is very simple, but useful to kind of get a grasp of. So what we do is we connect to our model registry. We extract all of the models that are either in staging or production stage. Now we only have staging present, but we could very easily go into the UI and change one of them, for example, into production. Then what the script does, it extracts IDs of these two models, one from staging, one to production, one from production, and it downloads it locally to the machine. So this would be locally to the CI/CD pipeline step, and also extracts the scores of a specific scores that are specifically interesting to us. And then it compares the scores, but I'm not seeing it here. for some reason. Yeah, right here. So if so, Challenger is production model, the model that is currently in production. And sorry, Champion is the model that is currently in production, and the Challenger is the one that is currently in staging. And if a given metric of a staging model, of production model, is less than, it's vice versa. If a given metric of a production model is less than, more than the one of a staging model, it then swaps basically the states of this model. So then we kind of promote a better model to be production one, and demote the worst model to 𝗏𝗏 state. Not even staging, but 𝗏𝗏. We'll never be looking into it again. And that's what that step does. And we run it via Azure ML pipeline by pointing to this model promotion script. We also need the service account token in order to do this, because we need to authenticate to Neptune. And then we have get latest model from production, and this is also something that we can add into scripts. Get latest model run. So this is how you could do a deployment step. It is not necessarily the way you have to do it, but this is how you could do it. What you do after promotion step, you do very similar things. So you extract all of the production models, of which there should be one. Then you extract ID of it, and then you simply download the serialized model. Once you have the serialized model downloaded, then you can do all kinds of magic with it. You can build a Docker container out of this model and push it to a Docker registry, not Docker registry, but container registry of some sorts, and then kind of save a pointer to that specific Docker image to Neptune, so that you can later reuse it for deployment. Or you can just straight on deploy it to production, meaning that you build Docker container, push it to a specific container registry, and deploy it to Kubernetes cluster, for example. And this is how basically the entire project would look like. Very basic project, so it still has a lot of missing pieces in it, like unit tests, integration tests, etc. But once you have all of this, then you can go into your pipelines, actually DevOps pipelines already. Since I have the pipeline pre-created, I will not do it again. I will just click to it and run the pipeline. Once I run the pipeline, I target the main branch. If I do it manually, of course, if I would do a but a merge to a master branch, it would run automatically. Once I run it, it starts executing. It will take some time to fully start. Yeah, now it's starting. It's installing all of the dependencies right here. So basically building a Docker container on top of which the steps in the DevOps pipeline will be running. The next one to be picked up will be linting. The unit tests, this will complete in matter of seconds. So the only longer one is this one. Let's wait for a few more seconds. Few more seconds. Sorry for making you wait, but yeah, that's it. So these ones just finished in seconds because we are not implemented. So linting unit tests and integration tests. And this one is actually just executing. It is really just executing this build pipeline script. And by doing so, it actually creates a new pipeline run right here, and it's running. I think it will take some time to succeed because I think all of the computes are now down, so it will need to spin up a new one. Idle nodes, busy nodes, unprovisioned nodes. Yes, so it will take some time, but eventually it will succeed. I think it will take around 5 minutes. And yes, that's it. This is what I wanted to showcase. This is also the step that the model validation is not the model validation step, but once this pipeline actually concludes, it will also run this step. So comparing models and promotion, meaning that it will kind of compare challenger and champion models against each other and automatically change the state in Neptune's model registry according to these R2, not R2, I think it was RSME metrics. Yeah, that's it. That's what I wanted to show today. I don't know if there were any questions. Let me check. Not too many. So one question, which example in the repo is it? So I am showing again. In examples, there is integrations and supported tools and AzureML. And all of this folder is basically what you have just seen implemented. And there are also some guidelines on how what you need to also additionally implement in order for automated authentication, basically. Okay, so I guess yeah. So one more thing. So this recording will be available in YouTube. So be sure to check out Neptune's YouTube channel. And yeah, I guess that's it. And see you most likely in the next workshop, because I do believe there will be more coming in the future. For me, it was really interesting. It was actually my first workshop online, but I did. So see you next time.